Okay, today we are going to talk more about functions. And if you left last class feeling like you were confused or didn't understand some of the stuff we went over, that's okay, because today is about taking it a little bit slower and really trying to understand what is going on and looking at some more aspects of this as well. Let's look at first the functional notation part again, because that can be sometimes a confusing part for people. What is the functional notation? And remember, the thing outside the parentheses is the name of your function. Inside the parentheses, we tell you what that input variable is. That means what's the variable that's really changing here. And then here, over here with the x squared, that's what this function does. It's the output that it generates. So when you put a specific number of x in, like say you want x equals 1, and if you did that, you'd write that as f of 1 would equal then 1 squared, which is 1. So f of 1 equals 1. The value of that function at 1 equals 1. So that produces the point 1, 1. Now let's say, what do functions look like? Because we haven't really covered this in any great depth. And I want to make sure that we do cover it before we leave functions behind. Functions, because each input can have only one output, okay, that means each x can have only one y. And if we look at this over here, we can see with this function, each x has only one y. With this relation, this x actually has two different y's. So therefore, this would not be considered a function. Okay? And we can tell whether a relation is a function or not by looking at the vertical line test. Does a vertical line pass through every single point of the function result in a situation where only one point crosses that vertical line along every point of the function? If it does that, then it is a function. If at some point that vertical line crosses the function at 2 points for the same x value, for the same input, then that is not a function. So therefore, this quadratic relation here is a function, whereas this circular relation is not a function. It does not pass the vertical line test because you can see it clearly crosses at 2 points. Now, we briefly went over domain and range and function name in this, and you can see when we're talking about this is our function name, and this notation here, f maps r to r, or the reals to the reals, that's saying our domain is going to exist in the real numbers, and our range is also going to exist in the real numbers. Now, our range might not be the entire real number, just like our domain might not be the entire real number, but they'll exist in the set of real numbers. And then f of x equals 3x plus 2, that's our function definition. Okay? So we've got our function name restated, we iterate what our input variable is, and then we tell you this is what that function does. So let's talk about evaluating expressions, because we had some homework last night that people might have been a little bit confused about. So if f of x equals 3x minus 2, we want to find f of 3. Well, f of 3 means every time you see an x, you're going to substitute in 3, and then just evaluate. Whoa. So we'll get 9 minus 2, so f of 3 equals 7. Now the second thing asks us to find f of 3. Now the inner thing, f of 3, we've already evaluated. So now I want to find f of 3, which means I'm going to find f of 7, because f of 3 was 7. So I can put in 3 times 7 minus 2, which is 21 minus 2, which is 19. So f of 3 equals 19. Lastly, we can do mathematical operations with these functions. We can add, subtract, multiply, and divide. So let's find f of 3 minus f of 2. Well, f of 3 we already know is 7, so let's find f of 2. Well, that's going to be 3 times 2 minus 2, which is 6 minus 4, which is 2. So f of 3 is 7, f of 2 is 2. So f of 3 minus f of 7 equals 5. Okay? Now here we have listed two functions, g of x equals x plus 1, h of x equals 2x plus 3. Let's find g of 3. So we'll substitute in a 3 squared plus 1, and we're going to get 9 plus 1 equals 10. So g of 3 is 10. Oops. Let me rewrite that so you clearly see that. Okay. Now let's find h of 3, which means, again, I'm going to substitute in a 3 every time I see an x. So I'm going to have 2 times 3 plus 3, which is going to give me 6 plus 3, which is 9. So h of 3 is 9. Okay. Now I want to find g of h of 3. Well, because I know this inner is h of 3, I know that value is already 9. Then what I'm really being asked is to find g of 9, which is just 9 squared plus 1, which will end up being 81, plus 1, which is 82. So g of h of 3 is 82. Now let's find h of g of 3. Well, g of 3 was 10. So I'm really being asked to find h of 10. So that's going to be 2 times 10 plus 3, which is going to be 23. So h of g of 3 is 23. Now let's find f of 4. We have f of x equals the square root of x minus 4. So f of 4 is going to equal the square root of 4 minus 4, which is the square root of 0, which is 0. So f of 4 is equal to 0. Okay? Now we want to find f of 0. So that's going to be the square root of 0 minus 4, which is the square root of negative 4. Is that allowed? No. F of 0 is not allowed because 0 is not in our domain. Our domain for this function is x must be greater than or equal to 4. Okay? Since 0 is not greater than or equal to 4, we can't evaluate this function right now at 0. Okay? So, not possible. What about g of 0? Well, if we look at g of x, we have 2 over x. Can we do 2 divided by 0? No, not possible with what you currently know. Well, it's not possible with what you currently know for f of 0. It's not possible at all for g of 0. It's undefined. Okay, now let's find f of g of 4. Or sorry, g of f of 4. Well, f of 4 we know is 0. Now that was defined. But then when we go to put it in, that's going to amount to having g of 0, which we know is undefined. So sometimes you can have the inner function defined, but then that output is not an input for your other function. Okay? Now we have g of 4 on the inner and f of that on the outer. So f of g of 4. So g of 4 is going to be 2 over 4, which is 1/2. So now f of 1/2, what's that going to be? Well, we said before with our f function it needed to be greater than or equal to 4. So again, we're going to come up with something that's not possible to evaluate. So be careful with your domains, because with some of these functions you might not be able to use the output of one function as the input. So what have we learned? Not all inputs can produce a function. Knowing what inputs can be used with a particular function is important. That's going to be what our domain is. Let's have some more practice with evaluating functions here before we end. We've got this function f of x equals 7x squared plus 3. We want to find f of 1. So we're going to have 7 times 1 squared plus 3, which is just going to be 10. How about f of 2? Well, that'll be 7 times 2 squared plus 3. 2 squared is 4, so 7 times 4 plus 3 is going to be 28 plus 3, which is 31. How about f of x plus 1? We don't always have to have a numerical input. Sometimes we might have a variable input. For this, we'll take 7 times x plus 1 squared plus 3. Now for this, we're going to have to evaluate x plus 1 squared. When we multiply that out, it's going to be 7 times x plus 1 times x plus 1 plus 3, which is equal to 7 times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1 plus 3. So we've got to multiply all those by 7, and we get 7x squared plus 2x times 7 is 14x plus 7 plus 3. And we get 7x squared plus 14x plus 10. So f of x plus 1 is equal to 7x squared plus 14x plus 10. Here we have a really odd function. K of x is going to equal m of x plus m of x plus 1, where m is another function, and we want to find each value of k of x. So, what we're going to do here is if m of x equals 3x, what's k going to be? Well, k of x will equal 3x, because m of x is 3x, and m of x plus 1 is going to be 3 times x plus 1. So this will just be 3x plus 3x plus 3, which is 6x plus 3. So k of x is 6x plus 3 in this situation. Now let's look at the next one. Here, m of x is x squared. And we're going to take it and put it into k of x. Well, k of x takes an m of x, which is an x squared, and an x plus 1 as well, which is going to be plus x plus 1 squared. So that's going to be x squared. And then remember, x squared plus x plus 1 squared is going to be x squared plus 2x plus 1. So in this instance, k of x will equal 2x squared plus 2x plus 1. Finally, we have m of x equals cx plus 2. So if we plug this into k, remember k is m of x times m of x plus 1, then k of x will equal cx plus 2 plus m of x plus 1, which is c times x plus 1 plus 2. So what we're going to get is cx plus 2 plus cx plus c plus 2. Combining like terms is going to give us 2cx plus c plus 4. So k of x in this instance is 2cx plus c plus 4. And that is the